We're going to look at power series and writing functions as power series. So the one thing that we're going to often fall back on is something like this. 1 over 1 minus x can be written as the sum of, as n goes from 0 to infinity, of x over n. But this only works for x. The absolute value of x is less than 1. So maybe instead of writing it like this, which you'll see all the time, let's write it as 1 over 1 minus a equals the sum of n equals 0 to infinity of a to the power of n for the absolute value of a less than 0. So this is what we want to write it in all the time. So that's a little trick. So what we want to do is write this. The first thing we want to do, 1 over 1 plus x squared, we're going to write that as 1 over 1 minus something. And hopefully it's not too difficult to see that that's going to be 1 over 1 minus x squared. So this becomes our a, or this equals our a. So we know that 1 over 1 minus x squared equals the sum, as n equals 0 to infinity, of minus x squared to the power of n. And this only works for x minus x squared. The absolute value of minus x squared is less than 1. So if we wanted to look at the radius of convergence, what is the radius of convergence of this? If minus x squared is less than 1, then x squared must be less than 1. So x must be between minus 1 and 1. Now, at the moment, we don't know what happens when x is 1 and what happens at x equals minus 1. But anytime x is between that, we can write this as this power series. And that's the same for most of these. So if we look at this one, a lot more difficult, a lot more tricky. We start with this. Remember what we want to write it as in the form of 1 over 1 minus a. That's what we want to write it as. So what we're going to do is we are going to factor out this 3 times 1 over 1 plus 16x squared. Then we can write that. Remember, we want a minus in here, so it can be 3 times 1 over 1 minus 16x squared. And that's our form. We've got it in the form that we wanted it in. So we can write this as soon as we get it in this form, we can write it as the sum, as n equals 0 to infinity, of a to the power of n for that a, the absolute value of a less than 1. So that's exactly the same thing that we're going to do here. We're going to do 3 times the sum of, as n equals 0 to infinity, of 16x squared to the power of n. And we can pretty that up but that's pretty well what we have. What is our radius of convergence, or our what values for this works at? Remember, it is the absolute value of 16x squared must be less than 1. So this equals x squared is less, the absolute value of x squared is less than 1/16. Therefore, x is less than a quarter or greater than minus a quarter. And that is pretty much how we do it. We wanted to have a look at a harder situation. Where is this series convergent? This is sort of going into the radius of convergency and stuff like that. Where is this series convergent? We could use the ratio test. Now remember, the ratio test basically is the absolute value of the n plus 1 term over the nth term must be less than 0. So if we write that out here, we're going to get 2n plus 1 times 4x minus 8 to the power of n plus 1. And I should just say this is the limit as n tends to infinity of this. So 2 of it, n outside of 4x minus 8 to the power of n all over n plus 1. And we're going to times that by n over 2n 4x minus 8 to the power of n. Now, lots of things here can cancel, but let's write it out. And remember, we're looking at the absolute value of this and the limit of that as n tends to infinity. So it's the limit as n tends to infinity of the absolute value of 2n to the power of 1 over 2 to the power of n times 4x minus 8 to the power of n plus 1 over 4x minus 8 to the power of n. What have we left with? Plus an n times an n over n plus 1. Lots of things can cancel here, so we're going to be left with the limit as n tends to infinity of, that's going to be 2. This is going to be times 4x minus 8 times n over n plus 1. And remember, we want that to be less than 1. So if we take this out, we can take this out because it's got nothing to do with n's. So we've got 2 outside of 4 outside of x minus 2, really, just to tidy that up a bit, times the limit as n tends to infinity of n over n plus 1. And we want that to be less than 1. So what does that give us? Well, this is 1. So what we've got is that x minus 2 times 8 must be less than 1. The absolute value of this must be less than 1. So x minus 2 must be less than an eighth, the absolute value. And then we might have to split it up into 2 little things here. So our radius of convergence, what we've got is that x minus 2 is less than 1/8, or x minus 2 is greater than minus 1/8. That's our radius. So x is less than 2 1/8, and x is greater than 1 minus 1 and 7/8. Okay, and that's our radius of convergence. We don't know what happens at x equals minus 1 1/7 or x equals 2 1/8, but we know anything between those two, and we can write it out a bit nicer. Something in between there, it is a convergent series. Okay.